All right, so this is your design and measurement intro. So I'm going straight into study sheet mode. You may add this to the back of your cover page or even the front of the booklet. Actually, the front of the booklet doesn't have a whole lot of room because it's all filled up. So if you just find a blank page along the way, I'm thinking of page 5 as a blank page. I'm jumping straight into just giving you what you really need. So for design measurement, we're going to calculate costs often, okay? So calculating the cost of labor, for example, will often involve just paying GST on top of the cost. So you'll have to add 5%. We do that by multiplying your final answer by 1.05. Other stuff, everything else, materials are taxed 12%. So if the question asks you to figure out the total cost, including taxes or after taxes, you want to multiply that by 1.12. But don't mix them up, okay? The question will be explicit about that. Here are some conversion rates that you have to have. I would say these are bare minimum. There are more, but 1 centimeter is 10 millimeters. 1 meter is 100 centimeters. Here we are talking area, right? Squared, right? So a squared meter has 10,000 squared centimeters, kilograms, grams. Here we go from the imperial system, so yards and feet. Foot has 12 inches. Now I'm doing squared, right? Squared yard would have 9 square feet, because if you square 3, you get 9. But it also has 144 squared inches, because if you square, actually this is not accurate. My bad, just get rid of this. Just have the 1 squared yard has 9 square feet, and 1 cubic yard has 27 cubic feet. Omit this part. And also have gallons and liters. 1 liter has 1,000 cubic centimeters, which is also 1,000 milliliters. Okay, so add that. I'm going to add a few more here. All right. So these are the conversion ratios. Make sure you have them on there. I want to say maybe that if you're dealing with feet and inches and its area, 1 square foot is 144 square inches. You're essentially squaring all of this, okay? And you get that. And 1 cubic foot has 1728 cubic inches. That might come in handy too. So again, I don't know what the province is going to do in terms of converting and asking you to convert. Sometimes they just flat out give you it. But this is a very popular one, going from cubic feet to cubic yards. I see that a lot. Squared feet to squared yards. I see that a lot. So we essentially set up a proportion and convert accordingly. Okay. I guess it doesn't hurt to say that 1 kilogram has 2.2 pounds. That is in terms of weight. That would help you as well. Okay, now formulas. Okay, so we have our basic shapes. The thing is that a lot of the basic shapes, we're going to sometimes carve things out or drill holes through it and whatnot. So you got to be comfortable with that. So I'm just going to call this a box or a prism, right? Rectangular prism. Definition of a prism is, I'll try my best here. You make your base. Okay. You make your base and then just add a height to it. And that essentially will give you a rectangular prism. Okay. It's a little off, but and if you're given 3 values, normally the first one is attributed to the length, and then the width, and then the height. Okay, so you have, I'm going to do it underneath and do the other shapes here. You have what we call the surface area of all surfaces, so top, bottom, sides, front, and back, right? So you would go 2 times length times width plus 2 times, well, you know what, it doesn't really matter which order you do them in, but I will go length and width is top and bottom, okay, because length and width, right? There's 2 of them. Then there's 2 times the length times height, that's front and back. And then it's 2 times width times height. That is, those are the sides. So if you think about it, this is top and bottom, and these are the sides. How do you know these are the sides? Because they have the height involved. So anything that has the height involved, right? This would be sides here and front and back, but I call it all around the sides. So that's our formula. So this would be the total surface area. I call this TSA, total surface area of this thing. But you also have to be comfortable with lateral surface area, where you get rid of this part. It's just 2 times length times height plus 2 times width times height. Okay. So that would be the instance when you're wanting to cover the sides either with paint or wallpaper or whatever, you would want to use this one. So sides only, okay? Basically sides only. If for whatever reason you're encountering a scenario where you're painting the walls and the ceiling, okay? If you want walls and ceiling, you're gonna take that original, and instead of having a 2 times length times width, because remember that represents the top and the bottom, we're just gonna have length times width. So length times width plus 2 times length times height plus 2 times width times height. Okay, so that will be the scenario at times. So we have to be prepared for that. Volume, okay. Volume essentially is the area of the base. Okay, if you have a prism that has the same shape as its base as you stack it up, right? Then you would say the volume is area of base times the height. This is, in a sense, the definition of volume, right? If you think about it, you figure out the area of the base, and then you stack them, right? You stack sheets of that on top of one another until you fill up that box, right? So that's why we multiply it by the height. So this is, by definition, the volume, which, if you think about it, volume is therefore, if area of base would be length times width, right? Times the height. So it's really length times width times height. So that's probably how you've learned how to state the volume or how to calculate the volume, right? So you've got a bunch of formulas that deal with that scenario, okay? Next, we have, and it's going to get probably a little bit messier than I would like it to be because I didn't prepare for it. Usually I go through all the notes and whatever, but I think we need to jump right into the formulas here. The next one would be pyramids. Okay. And I will talk about the square-based pyramid. Square-based. There's a rectangular base, but I haven't seen that one. So what you do is you kind of make a slanted square like this as your base, and then I go from the center, I go straight up somewhere, and then I just make the sides connect to each corner. There we go. You've got your pyramid. And oftentimes they will give you the length the side length of the base, we call that A. Okay, so if you're given the whole thing, we call that A. If you have, I'm going to use a red pen for this one, there's a slant height. Okay, this is the slant height, we call that S. It looks like a 5, but it's an S. And you've got the top and bottom, right? We've got the actual height. So you gotta watch out. The actual height goes right to the center and makes a 90 with the plate, the bottom plate, right? So that is our height. So don't mix that up, okay? Slant, we're talking outside. Height, we're actually talking inside. So to figure out the total surface area, we would go A times A, okay? A times A, which is A squared, plus, watch how I'm going to do this. So I'm going to derive it a little bit. We've got 4 triangles if you think about it all around. So if you think about it, the area of a triangle is, there's 4 of them, and the area of just one triangle would be base times height. And I'm now talking about the slant height because it's this triangle here. So it's base times height divided by 2. So if you want to keep the formula that way, that is fine, but it simplifies. Because 4 divided by 2, because eventually you divide, right? Even if you go 4 times all of this and then divide by 2, you end up with just 2 here and just 1 there. Okay, the 2 goes in there 2 times, 2 goes in there 1 time. So simplified, this is the one that I prefer to use. It is really 2 times A times S. Okay, that is how you find the total surface area of a pyramid. The lateral surface area, that'll be the case when this is stacked on top of like a box, let's say. You're not interested in the base at that point because we only want exposed surfaces. So the lateral is kind of like the sides, would only be 2AS, 2 times A times S. Okay? Sides only. No base. Okay? Whatever works for you there, but no base if you do that one. Okay? And for volume, if you think about it, it's still area of base times height. Okay. However, area of base is A times A squared, times the height. And here we're talking the actual height. Okay, volume, you're wanting the inside space, right? You wouldn't want to use the slant height here. So it's area, A times A, which is A squared, times height. But this is pinching down, right? It's not a square stacked on top. It's not a rectangular. So you divide everything in by 3. Okay? That is the key here. It's A times A, which is A squared, times the height. But you got to divide it by 3 because of the pinching. Okay? So that one, or some textbooks have 1/3 A squared times H. Regardless, they're doing the same thing. Okay, so there you have your surface area and your volume. Additionally to pyramids, you gotta watch out. Sometimes we have to figure out the slant if you have the height, or you have to have the height if you want the slant. Okay, so you gotta use your Pythagorean theorem. Okay. Pythagorean theorem at times. So what we know, remember, if we were to cut out this triangle kind of sideways, this would be what we consider the slant. Okay, S. This would be your height. Okay, this one right here is the one that goes down the center. And this is, if you think about this one, it's A divided by 2. it's half of A, because if A is from end to end, right, from end to end right across the plate, this is A divided by 2. Okay, so if you have that, if you have A, if you have the dimensions of that square base, then you just split it in half to make your little triangle. You only need to do this if, for example, the question gives you the slant, okay, and then they ask you for the volume. Well, you can't use that for the volume. You got to find out this one. So you'll have to use Pythagorean theorem to find the other, okay? So what we know is that slant squared is equal to h squared plus a divided by 2 squared. Furthermore, I would just use this one. Slant is h squared plus a divided by 2 squared. So this is if you want the slant. If you want the height, okay, that would imply that you know what the slant is, right? Then you would go slant squared minus, because remember, this is your hypotenuse, that's the longest side. You square that, you subtract the other leg from it. But you got to watch out that you don't double divide by 2. Okay, so I kind of have to increase my root a little bit to make sure everything is under the same roof. Okay, this is if you want the height. Okay, so that's kind of like an aside. It comes from this. If the question gives you the slant and you need the volume, you want to input the slant in there and then do this calculation to figure out the height, because you need that for your volume. Okay, we'll do more of those later. Just make sure you add this to your study sheet for now. Next, we've got the sphere. Okay, or should we do cylinders first? Let's do cylinders first. Cylinders. If you ever see or hear the word, it's a cylindrical shape or whatnot, you know what shape we're talking about. It's a circle with walls to it, right? So circles for the top and the bottom. So for the surface area, the total surface area, we go 2 pi r squared. Remember, 2 pi r squared because you've got a circle and a circle. Right? The top is pi r squared. This is pi r squared. And for the sides, we go 2 pi r times the height. Okay. And if you think about it, the circumference of a circumference is 2 pi r. Okay. That's the distance around a circle, right? So if you make a mark and you measure the distance around, that is circumference, okay? I guess I should say that right across is diameter. Diameter is 2r, okay? I think a lot of you already know this. If it's all you want is lateral surface area, like just the sides, you don't want the top or bottom, it's simply this, okay? So 2 pi RH, that's it. So these are formulas that I would definitely have on my no top and bottom. So we were going to want to exclude them sometimes, okay? The volume is still area of base, which is pi r squared, times the height of this, okay? So if you think about it, this is area of base times height. And there you have it. That's the volume of a cylinder. And last but not least is sphere. Okay. So the sphere is, what I do is I just make like almost like an ellipse or an oval, and then this, right? So it's kind of like the image that this is so we have the radius here, and so the surface area, total surface area, is 4 pi r squared, and the total volume, right, the volume is 4 pi r cubed divided by 3. Okay, so it's actually very straightforward there. This is called a hemisphere. Is simply, it's half a circle. Yes. Okay. So if you want the surface area of the entire thing, including the base, like imagine this has been sliced open and now there's like a base to it here. This would be pi, should be careful. Think about it this way, it's half of that, so it's 2 pi r squared, okay, for the outside, but now we got to add another pi r squared. This is the base, this base right here. So the surface area, the total, I should call this the total surface area, would be 3 pi r squared. That is if you have a scenario where you make hemispheres but you're also kind of exposing the bottom, right? If you just want lateral surface area, like don't want to include the base, it's just the 2 pi r squared, okay? This is the one where you include the base, this is the one where you don't. The total volume is half of this. It ends up being 2 pi r cubed divided by 3. So instead of 4 pi r cubed, it's 2 pi r cubed. What's the time of the video? I gotta make sure it's already a bit over. But I think we've got it figured out. Have these formulas on your study sheets. This is the bare minimum that I would expect you to have on there. If you need to add any more, we'll do that. Thank you.